Median of two sorted arrays. Given two sorted arrays names1 and names2 of size m and n respectively, return the median of two sorted arrays. The overall runtime complexity should be order of log m plus n. Okay, when we look at this XML, this is simple 1, 3, and 2. When we match the arrays, we got 1, 2, 3, and the median is just 2. When it is having even numbers 1, 2, 3, 4, we will take middle values, two middle values, and now we're divided by 2, so we can get the median values. Okay, so let's explore more XML. So I will have this array, first array, and the second array is like this. So they already sorted in their individual arrays, right? But when we merge, we need to sort that again, right? So I took everything, and then I put everything in one array, and then I sort it. Okay, so the way we can do this, right, we can sort it. Then I will take the median value. If the total numbers is even number, we will take two middle values and divide it by 2. If the total count is just an odd number, we will take only the middle value. Okay, so we can get the median. So here we have 7 numbers, right? So we will get index number 3 is the median value, so we got 4 as a median. Okay, so the way we can do is we can take everything from this array, and then we will put in the auxiliary arrays, and then we will sort that array, and then we will try to get the median value. Okay, but it is saying we need to solve order of log m plus n. So that means we cannot sort it, because if we want to sort an array, it's gonna be order of n log n at least, right? So we don't need that complexity. So we want or log. So log, most of the problem to get the log is using the binary search, right? Like dividing the arrays or dividing the arrays we have, right? And then we can solve without creating new arrays, without sorting. Okay, the way we can do is we will divide it two partitions. Okay, two partitions, and then on the left partitions we will get left partition and right partition, right? So we got two partitions. So if they are equal, I mean you see the space means the time I just make it for the partitions. Okay, on the left side of the space, it is the left partition. On the right side of the space, it is the right partition. So the total count is 8. At the time, we need to get two middle values, right? And then we will take the maximum value from this left array, from the left partition, and then minimum values from the right partition. So we got 3 plus 4, and then we will divide it by 2, and then we got the median value. Okay, so here, yeah, how to partition the arrays. Okay, we will talk about that later. Now, for now, we just see the space. Okay, on the left partition and then right partition. Now the array is having 9 elements, right? So we need only one middle values, right? So we will compare. I'm sorry, we don't need to compare. On the left partition, we save 4 items, and then on the right partition, 5 items, right? So we will take the minimum of this side. Okay, so here 6,7, and then when we look at this XML, like 1, 2, 3, 4, 5, 6, 7, so it's gonna be like this, right? On the left partition, it's gonna be 3 elements, and then like this. So we will take the median smallest numbers from the right partition, so we get 4. Okay, let's do that way. So okay, how can we partition it? Okay, now we will check the total. Here, how many elements in our in both arrays? Like we have 4 elements from the first array. The total is gonna be 8. Okay, so 8 means every elements in both array, 8, right? The count is 8, so the half of the array is gonna be 4. So that means the left partition should be 4 and then the right partition should be 4. Okay, so when the total is odd number, for now we have 9 elements. So on the left partition we will have 4 elements and then 5 elements on the right partitions. Okay, so 4 elements should be in the left partition. So we have 2 arrays, right? So we will take some from this array and then we will take some from this array, because we need to sort that too, right? So we will take some elements from this array for the left and right partition. We will take some for the left and right partition. Okay, so 1 and 2 and then 1 and 3. How we get that? So for now here we have 4 elements, right? I will take only the half of this array because I want to take half of this array too, right? So I will take half and then I will take half. We can see the one we took is correct or not by comparing 2 and 5, 3 and 4. If 3 is less than 4 is correct, 2 is less than 5 correct. That means the left partition is gonna be every element on the left partition should be smaller than the right partition, right? So now 2 and 3 are smaller than 5 and 4 respectively. So we think, okay, the way we choose is correct. Okay, then we will compare we will try to get the median value, right? So after we partitions, we will think, okay, now we partitioned correctly, so we will take we will take the smallest value in the left partition and then the maximum value on the left side and then minimum values on the right side. So 3 and 4 we will divide it by 2 and then we got 3. Okay, here we got we have like this, right? For the first time, okay, we will take now 9, right? So we should have 4 elements on the left pointer. So we will just think like that. Okay, I will take 1 4 and then I will take 1 2. But when we check the order, it should be 1 1 2 3, right? It shouldn't be 4 because every element on the left partition should be smaller than the right partitions, right? So okay, when we check this one, 4 is not smaller than 3, 2 is smaller than 4, so we will check cross in the crossway, right? 2 is smaller than 4, but 4 is not smaller than 3. Okay, so we will not take that one. The binary says it's gonna become here. So we will just check median and then left pointers and then right pointers, right? Median is here, so we divide it from here, right? And then if it is not working, we will divide it this part too. So okay, now we got 2, so we divide it like this. Okay, what about like this? So at the time we got only 1, but it should be 4 on the left side, right? So we will take more elements from the left from the right partition. Okay, so we got 1 and then 1 2 3 for the left side. So we will check again. 1 is smaller than 4, 3 is smaller than 4. Okay, so we partition correctly. So we got the correct partitions. So we were trying to get the median value because the total count is odd number. So that means we need to get the minimum values from the right partitions because the right partitions have more extra 1, right? So we only have to take the smallest numbers from the right partition. So we only need to compare 4 and 4. They are the same, so we will just return 4. Okay. Okay, when we look at this example, we don't have like this. Okay, now 7 elements. That means we need to have 3 elements on the left pointer on the left partitions and then 4 elements on the right partitions, right? Okay, so we will just look at this one. Okay, we will divide it. Okay, there is 2 elements. Okay, I will take 1 element and then 2 elements from this side. Okay, so at that time 6 is not smaller than 3. Okay, so we cannot take this 6 for the left partitions, right? So okay, I cannot take that one. So this is gonna be the right side, and then we need to have 3 elements on the left partition. That's why we just got 1 2 3 on the left side, and then right side is having 4 elements, right? Okay, 3 is greater than 6, so it's correct. Okay, and then because the total count is odd, we can take the smallest numbers on the right side. Okay, so 4 is the smallest numbers on the right partition, right? So we will return just 4. Okay, so let's do that. But for the first case, because we have to take care of this, we need to check the numbers, the count numbers, right? The numbers of the count of the numbers. So now it's 4 4 4 5 2 3, right? So we have to take half of the arrays which has smaller length. That's why if nums1 is having many elements, we should put that one as a second is in this place, right? Only if the nums1 has smaller count than nums1, we need to follow this step. So we can work at that one. So okay. So if I just want to swap that one according to the length. So if the number 1 length is greater than numbers 2 length, GTX, right? Okay, so I will swap those num1s and nums2 for the nums1 and then num2. So we can think nums1 has always small count of numbers. Okay, smaller count of number than numbers 2. Okay, so let's try our logic. I will need to check how many elements on the left side should be on the left partitions. Okay, right? To partition, we need to know the count value, right? So total number is gonna be nums1 dot length plus num2 dot GTH, right? Okay, and then we got the total. So half it's gonna be total by 2, right? So when we have 9, we got 4, right? When we have 9, in this example, when we have 9, half is 4. That means it should be 4 elements on the left partitions, and then right partition is gonna be 5 elements. Okay. Okay. So let's try to divide the arrays. Okay, so let's try to partition. So left pointer is gonna be just 0, and then right pointer is gonna be nums1 dot -1, right? Okay, and then I will just loop till y because we need to return anything, right? We need to return. Okay, so in the loops. Okay, so let's try to get the middle values. Okay, middle value first. Okay, I'm sorry, because they all are sorted, right? So we don't need to look for the middle value 2 times. We will have to take the middle values, and then if it is 2, we need to save 4 elements on the left partition. So we want 2 more, right? 2 more elements. So we will just check the middle values here. Middle 1 is left. If left less than r, we will take the middle values, right? Right minus low, right minus left, right pointer minus left pointer by 2. This is the way we want to get the middle values. Okay, but if there is nothing, if there is nothing, that means if the left pointer is less than or greater than right pointer, that means if there is nothing from this array. So if we think about that, we will get 0, right? We don't need that 0 because we will not take this 0 for always, so we cannot take that one. So I will just return -1. Okay, so and then middle 2 is gonna be this one. For this partition, how many partition we need to partition, right? So we need 4 elements on the left partition, right? And then we got if we got 2 elements for this, for example, now we want 4 elements, but we got 1 at the time for -1, right? Mid 1. And then this one is gonna be mid 2, right? Because we start from the 0 0, that's why I need to -2 for this, because we index starting from 0. Okay, so we were divided, we were partition. Okay, and left one's gonna be left one, means this one. Okay, and then right one's gonna be this one. Okay, the same way, left 2, right 2. Okay, okay, we will just think mid 1 greater than equal 0 or not. Okay, if mid 1 is greater than equal 0, that means we will take num1 dot mid 1, right? So if it is not, that means if it is -1, that means there is no elements in this array. At the time, we will just take minimum value of int. Okay, right, this one we got what we want. Okay, so this is the same, mid 1 plus 1 less than numbers of and GTH length. Okay, so at that case we need to take if it is only if it is less than, we will take mid 1 plus 1, right? If it is not, we will take maximum value of integer value. Okay, I think the same way, mid 2 is greater than or equal 0. If it is not, if it is greater than, we will take mid 2 of the nums2 array, and then we will put like this. And then for the right 2, the same way, mid 2 plus 1, and then mid 2 greater than less than mid 2 dot length. If it is, oh, this one should be nums1, right? So nums2. Okay, and then x maximum. Okay, so we partitions, right? Left 1, left 2, right 1, right 2. Okay, so we can compare if we partition correctly or not, right? So if left 1 less than or equal right 2, so that means this one, this index, right? They are just an index, right? Left one is gonna be this index, left 2 index is this one, right index 1, right index 2, right? So we can just compare left 1 is less than right 2, and then left 2 less than right 1, right? So okay, left 1 less than equal right 2, and left 2 less than equal right 1, right? If they are equal, we partition correctly. Okay, so we need to check the total is even number or not. If it is even, okay, if it is even, we need to return the smallest the maximum value from the left partitions, and then the minimum value on the right partitions, right? So return, we will just check, I will use the min function, and then right 1 comma right 2. Oh no, I mean this one is both of them are smaller also. Okay, if they are the same, if, oh no, I mean if it is even number, if it is even number, we will return max dot max, I mean left 1 comma left 2. Okay, so from this one we will take the maximum value n plus max dot min right 1 right 2. Okay, we sum them up and then we will divide it by 2, right? Okay, and then if it is not, that means if it is not equal, that means if it is not equal to 0, that means the total number is odd number, so we only need to take the minimum value of the 2 array, or right on the right side. Okay, so if this one is correct, if we partition correctly, okay, if it is not, else if oh I'm sorry, left pointer 1 left 1, if this one is greater than right 2, at that time we need to change our right pointers, right? Because we use left pointer, right pointer, we will have to change other division. So right pointer is going to be mid plus 1, right? Else, that means left 2 is greater than right 1, right? At the time left equal mid plus 1. Oh, I'm sorry, okay, plus 1. So that means mid minus 1, right? So here we just divided half half, right? Half half. At the time left 1 is greater than right 2. At the time we need to change our middle values, right? This mid, oh, I mean mid 1 values, right? Okay, I need to change here this value, okay, mid 1 value, so I need to over here, right? So now we got left partition, right partition for the first time, and it is greater than the right 2, so we will change the mid 1 value, so we will just get 1 like this at the second loops, right? And then because of the mid is greater than that, so we will just get like this. Okay, so until we partition correctly, we will keep looping and then partition correctly only if it is partitioned correctly, and then we will try to get the median values. Okay, and then because we don't need to care about the middle 2 values, because middle 2 is just pennies on the middle 1 values, right? Okay, so I got this one mid 1 index out of bound exception. Okay, let's see it again. Number one, if we were swap this one, oh wait, I need to return this one too, right? Okay, but it will not be the error cause just okay, and then total is gonna be num1 length plus num2. It's correct. Totals by 2, we got half, and then number 1's length, so we got right pointer and the left pointer. If left pointer is less than equal right, so it's gonna be like this. Okay, half. Oh, where is this for? Oh no, this is not for, right? This is just a half. I mean, I meant this one. Maybe that's why. Yeah, let's try this one again. I just put the constant value. Okay, so let's try to submit this one. Okay, so that's it. Thank you.